Maximize z equal to minus x plus 2y subject to the constraints x greater than or equal to 3, x plus y greater than or equal to 5, x plus 2y greater than or equal to 6, and y greater than or equal to 0, and x is greater than or equal to 0. Now, first let us take the inequality x greater than or equal to 3. Take x is equal to 3. Consider this is equation number 1. Next, you consider the x plus y greater than or equal to 5. Take x plus y which is equal 5. Consider this is equation number 2. Let us find any 2 points on this line. Take x is equal to 0, then y is equal to 5. Similarly, take y is equal to 0 and x is equal to 5. Therefore, 0, 5 and 5, 0 are the points on the line x plus y which is equal to 5. Next, you consider x plus 2y greater than or equal to 6. Take the equation x plus 2y which is equal to 6 and consider this is equation number 3. Let us find any 2 points on this line x plus 2y which is equal to 6. First x and then y. Take x is equal to 0. So 2y equal to 6 and then y equal to 3. Take y is equal to 0. Then x is equal to 6. Therefore 0, 3 and 6, 0 are the points. Solving equation 1 and 2 so that we can find the point of intersection of 1 and 2. What is equation 1? X equal to 3. What is equation 2? X plus y which is equal to 5. Substitute x is equal to 3 here. So 3 plus y equal to 5. So what is y value? Y value is equal to 5 minus 3. That is y value equal to 2. Therefore, point of intersection is 3, 2. X value is 3 and y value is 2. Solving equation 2 and 1. Solving equation 2 and 3. What is equation 2? Equation 2 is x plus y which is equal 5. What is equation 3? X plus 2y which is equal 6. Now change the sign. It is minus, here minus and here minus. X minus x, 0. Y minus 2y minus y which is equal 5 minus 6 minus 1. So y which is equal plus 1. Equation 2 implies substitute y is equal to 1 in equation 2. So x plus 1 which is equal to 5 and then x is equal to 5 minus 1 that is 4. So x is equal to 4. Therefore, point of intersection is 4, 1. Solving equation 1 and 3. What is equation 1? X is equal to 3. What is equation 3? X plus 2y which is equal to 6. Substitute x is equal to 3 in equation 3. So 3 plus 2y equal to 6. So 2y equal to 3. So this implies what is y value? Y value is 3 by 2, that is 1.5. Therefore, the point of intersection is 3, 1.5. You see the first equation, x is equal to 3. Let us draw the line x is equal to 3. So this is called x is equal to 3. And this is equation number 1. Next, you see the equation 2, x plus y which is equal to 5. The points 0, 5 and 5, 0 are points on the equation number 2. Now 0, 5. So this is called 0, 5. And then 5, 0. This is called 5, 0. Now join these 2 points by a scale. So this is called x plus y which is equal to 5. And this is called equation number 2. Let us construct the equation number 3 on this graph. X plus 2y which is equal to 6. It is passing through 0, 3 and 6, 0. 0, 3. Here the point is 0, 3 and 6, 0. Here this point is 6, 0. Now let us join these 2 points by using the scale. So this is called line number 3, that is x plus 2y which is equal to 6, and this is called line number 3. So let us calculate the common feasible region. First you consider equation number 1, x is equal to 3. So what is the corresponding inequality, that is x is greater than or equal to 3. So take a point which is not on the line. Say for example 0, 0. This point is not on this line. I can take and substitute the inequality x is greater than or equal to 3. Substitute x equal to 0 here. So 0 greater than or equal to 3. 0 greater than or equal to 3. That is not true. Substitute x is equal to 0 here. 0 greater than or equal to 3. It is not true. So the half plane which contains the 0, 0 will not be the solution. So for this side we should share it. For this line x is equal to 3. So let us mark here. For this line, shading should come in the right hand side of this line. Next, consider the equation number 2. Take a point 0, 0 which is not on the line x plus y is equal to 5. Substitute the corresponding inequality for x plus y equal to 5. The inequality is x plus y greater than or equal to 5. Substitute x equal to 0 and y equal to 0. 0 plus 0 is 0 which is greater than or equal to 5. It is false. So the half plane which does not contain the origin will be the solution. So this line x plus y which is equal to 5 splits the entire plane into 2 parts. This part contains the origin and this part contains does not the origin. So the plane which does not contain the origin will be the solution. So I can share this side for the equation x plus y equal to 5. That will be the area x plus y greater than or equal to 5. Next, the last line x plus 2y which is equal to 6. We consider this line which splits the entire plane into 2 half planes. Let us calculate, let us decide which one is the feasible region for x plus 2y which is greater than or equal to 6. Take a sample point, say for 0, 0 which is not on the line x plus 2y which is equal to 6. Substitute the corresponding inequality x plus 2y which is greater than or equal to 6. Substitute x equal to 0 and y equal to 0. So 0 plus 0 is 0. 0 greater than or equal to 6. That is not true. So the half plane which does not contain the origin will be the solution. So for this line the shading should come this side. This side shading should come. So I'm marking here. Next, let us calculate the feasible region for all the three inequalities. Number 1, shading should come in this side. For line number 2, shading should come this side. For line number 3, shading should come this side. So see how many areas are there. Area 1, area 2, area 3, area 4, area 5, area 6, area 7. So out of these 7 areas, which is common feasible region for this entire inequalities, x greater than equal to 3, x plus y greater than equal to 5, x plus 2y greater than equal to 6, and y greater than equal to 0, and x greater than equal to 0. So let us calculate the feasible region for all the inequalities. First you consider this line x, which is equal to 3. For this line, this side shading is coming. So let us mark the places. Here one time shading will come, here one time shading will come, here one time shading will come, here one time shading will come. Consider the line number 2. This side is shading is coming, so here one time shading will come, here one time shading will come, and then here one time shading will come. Okay. Next you consider this line x plus 2y, which is equal to 6. For this line, shading is coming this direction. So what will happen? Here one time shading will come, here one time shading will come, and then here one time shading will come, and then here one time shading will come. Okay, so you consider this region. Here 3 times shading is coming. In rest of the places, here 2 times shading is coming, here 2 times shading is coming, here 1 time shading is coming, here 1 time shading, here no shading at all. That means the maximum number of shading is occur here, and this is unbounded region also. Now the region for shading is here. So this is the feasible region. Now let us shade these places. See, this is the point of intersection of line 2 and line 3. See, point of intersection of line 2 and 3 is 4, 1. This point is called 4, 1. And this is the point of intersection of line 1 and line 2. Line 1, line 2, point of intersection. See here, solving equation 1 and 2, we are getting the point of intersection of line 1 and line 2. So 3, 2. So this point is called 3, 2. And this is the point 6, 0. That's all. Only 3 corner points are there. This is corner point 6, 0, and this is 4, 1, and this is 3, 2. So the corner points are, what are the corner points? 6, 0, and 4, 1, and then 3, 2. Is it equal to minus x plus 2y? Now substitute x is equal to 6. So minus 6 plus 0. That is, z value is minus 6. Next, substitute x is equal to 4. Minus 4. Y value is 1. That is 2. Minus 4 plus 2. That is minus 2. Substitute x is equal to 3. Minus 3. And then y value is equal to 2. 2 to 4. 4 minus 3 is 1. Now, we got actually the 1 is the maximum value. But here, the question is maximum is z equal to minus x plus 2y. Here, 1 is the maximum value. It may be 1. It may be the maximum value or it may not be. So, we have to verify it. For that, we consider this minus x plus 2y. It is maximized. So put the greater than symbol, not greater than or equal, greater than symbol. And then what is the maximum value we got here? 1. So substitute here 1. Take the equation minus x plus 2y, which is equal to 1. Consider this is equation number 4. Next, let us find any 2 points on this line. So x and then y. substitute x is equal to 3. So when x is equal to 3, what will happen? This is minus 3. Take this minus 3 to the right hand side. Plus 3. 1 plus 3 is 4. 2y equal to 4. Y is equal to 2. Substitute x is equal to 0. So y is equal to 1 divided by 2. That is 0.5. Therefore, the points are 3, 2 and 0, 5. 0, 0.5. Now let us mark these points. 3, 2. Already it is marked here. And then x is equal to 0, y is equal to 0.5. This point is called 0, 0.5. And 3, 2 is marked here. Now let us draw a line. Let us draw by using dotted lines so that we can easily differentiate this line. So here also the 0, 0 is not a point on the dotted line. So what we can do, we can take the 0, 0 and we can substitute in this inequality. Substitute x equal 0, y equal 0. So total 0. 0 is greater than 1. This is false. False means the half plane which does not contain the origin will be the solution. So this side shading will come. So here we have lots of common region between yellow color feasible region and this region for x minus x plus 2y greater than 1. So what we can say here, there are common points. Between the inequality minus x plus 2y greater than 1. This inequality shows this region, this common region. Okay, already the yellow color region is the feasible region and the blue color line which has a region this side only. So minus x plus 2y greater than 1 represent this side region only, this half plane. Already here feasible region is there. So we have the common point. So what we can write, there are common points between minus x plus 2y greater than 1 and feasible region. So this implies no z max. That means the maximum value of z is not exist. No z max. Suppose if we do not have the common region between minus x plus 2y greater than 1 and the feasible region, then we have the z max. So in that situation, what could be the z max? That is z max which is equal to 1. That is the maximum value of z is equal to 1. But here, what happened here? We have the common points between minus x plus 2y greater than 1. That means this region and the feasible region. So we have the common point. That means there is no maximum value of z. So we can write no z max.